Redox half-equation is another subtopic. How can we write a redox half-equation? Okay, now this is a reduction process. Reduction is a redox reaction, yes. So how can we split it into various halves and also balance it accordingly? That's what we are looking at now. For example, C2 plus Zn equals Zn2 plus C2. This is carbon. Sorry, copper, zinc, and zinc. One process is oxidation, another part is all reduction. So how can we split it and balance it? Okay, let's start with one process, reduction process. All right, so from Cu2 plus to Cu. Okay, now don't forget the reason why. Okay, this is reduction because of the charges we have. Copper here is +2, but copper here on the normal state is what? Is 0. So as we're moving from +2 to 0, reduction takes place. There's a gain of electron here. Now the reason behind these two, we must make sure that in chemistry, all equations written must be balanced. You must take note of that. So from Cu2 plus to Cu, something is missing, all right? So it's just like saying, if I say +2 minus 2, what would I have? I will have 0. So that both sides will have what? Will have a charge of 0. That's the reason we have -2, okay, added to what? To the copper 2 ion. This E stands for electron. Don't forget that. 2 electron, okay, compromises this and give us what? 0 ion in the product. Okay, so I look at this now. Both of the reactants, the whole of this had a charge of 0, while the whole of this was have a charge of 0, and the equation is balanced. Okay, first of all, we split to their half reaction and balance it by the corresponding number of electrons to make sure that both sides have what? The same number of charges. That is why the splitting has to be done. Now the next part, the second part of the reaction, it will be your oxidation reaction. Okay, at this point now, zinc here, okay, zinc here is 0 because it's a neutral compound. When it now moves to the other side, it becomes what? +2. So at this point, zinc is losing electron. Okay, it becomes +2. So what should we do to make sure that we have both reactants and products have the same number of charges? So since zinc is losing 2 electrons, we must balance this zinc by what? By 2 electrons. So that if I say 2 plus, okay, -2, this is +2, okay, -2 will give us what? 0. So the charge of zinc here correspond with the charge of zinc in the what? In the products. So at this, we now balance both our reduction half, and what? Oxidation half, what? Reaction equation. Let's look for another example for more clarification. For example, we have chlorine plus bromine ion give us what? Chloride ion and bromine atom. So from where to where is our reduction, and how are we going to balance that? So from this point, at this point, okay, chlorine is 0 of charge and -1. So from this point to this point, there is one process that's taking place there, and then from here to here is what? It's another process. So what process is this? This is reduction. Don't forget, reduction process, which is gain of electron, whereas this is our oxidation process. Now, how do we balance this? Bromine has 0 watts charge at this point. It's a neutral element. As you can see, from -1 to 0 is what? Is losing electron. So it's an oxidation process. So how do we balance this? So we balance this in this manner. All right. First, oxidation. Okay. So we have 2Br minus give us what? 2Br. So to make sure that we have the same number of charges, that is why we have 2E minus, because this is 2 atoms of bromine. You need to put 2 mole to correspond this, because 2 times 1 is equals to 2. 1 times 2 is equals to 2. So atoms here is 2 in the reactant, 2 in the product. For us to have the same number of charges, we add 2 electrons to the side that is lacking the electron. At this point now, this side is ending 2 electrons, whereas here is 0. All right? So we must add 2 electrons to the side that is less, so that we can have a balanced charge for both of the reaction. So that is why we have this. Okay, that's what we have here. Here is minus 2. 2 times minus 1 is minus 2. Here is 0, right? So 2 times minus 1 is minus 2. So the reactants and the products have both what? The same charge. All right, same thing is applicable to the next half, which is your reduction half, which is from where to where? All right, from chlorine to chloride ion. All right, so here is lacking electron. That's why we added 2 electrons to the reactant side to correspond with the number of charge we have in the product. So this is another example of redox what reaction. Let's look for more example for more clarification. Okay, chlorine plus iodide ion give us what? Chloride ion and iodine. So what is going on here? From this chlorine to chloride ion is reduction process. So you split it into this form, is that okay? Then from iodide ion to iodine is what? Oxidation process. So this is a reduction half equation. Another one is this form, okay? You split it, magnesium to Mg2 plus, then see, you can also balance it. I know you know how to balance that. To balance it is very easy. Just follow the example I've given you and you balance it. Another example is this redox equation, okay? Now you split this, for example, yes, let me bring everything out so I can explain at the same time. All right, so at this point, the oxidation half equation is from where? Now, this place is like saying K plus slash I minus. Then K plus slash what? I minus. So what is common here? K and K is common. So K will go with K. That's why we have I minus. Okay? First, from this point, as you can see, to this point, there's a process that takes place, and here to here, process has taken place, all right? And you balance it accordingly. So this is my oxidation half equation. Why? Because from minus 1 to 0, this is 0, is loss of electron. Then from 0 here to minus 1 is what? Gain of electron. And you balance it based on the number of electrons that they have. There's another example in this form. So you break this compound, this equation, into their respective halves. Okay? So from Mg to Mg2 plus, and then Cl to Cl minus, and you balance your equation based on the number of charges that we have. So this is another example of reduction half equation. Then the last one is when you react cerium with tin, and you have this, and use your reduction half equation, C4 plus 1A minus, because when you do this, it's like saying 4 plus minus 1, that equals to what? Plus 3. So at this point, there and here, they have the same number of charges. Plus 3 and what? Plus 3 and plus 3, and so on and so forth. So this is how you split the equation into your respective halves, and you balance it accordingly. Note, you must balance the equation after splitting. All right. Let's move to the next subtopic, which is how do we balance redox equation? Overall balancing of redox equation. For example, you are given this problem, all right? Iron plus chromium, okay, oxide ion with ion that gives us iron 3 and chromium ion. Now, we are going to balance this equation accordingly, okay, using what? Using half-reaction method in an acidic medium. Now, before I start balancing, let's look at the steps involved. All right, there must be a step you have to follow to make sure that the equation is duly balanced. First of all, balance all the atoms that aren't oxygen or hydrogen. The next step, balance the oxygen using what? Water. Don't forget this. All the oxygen must be balanced with what? With water. Don't forget that. Then all the hydrogen must be balanced using what? Hydrogen ion. Don't forget these 2 points. Point 3 and point 2 are very vital. So you don't mix up. This is acidic medium balancing. Okay, let's start the process and see how we are going to end our balancing. Okay, so first of all, break these 2 ions into their 2 halves, in which is done already. So I will kick off from here. So you can start from any parts to balance. For example, let's start from reduction half. Okay, so we have Cr2, let me take it directly, but it will be long. Let's start from reduction half. reduction half. That is from where Cr2O7 2 minus to where we have Cr3 plus. Now, from the first state, balance all the atoms. At this point now, the atoms are not balanced. Look at it very well. Here we have 2 chromium at the reactant. We have just 1 chromium at what? At the product. What do? 2 chromium, move this 2 to this point. We balance your chromium. 2 chromium atoms are in the reactant. 2 at what? At the product. What's our next step? Balance the oxygen using what? Using what? Water. At this point, we have water. We have oxygen in the reactant, and we don't have oxygen in where? In the product. What do? We introduce water so we can have where? We can have oxygen. So how do we give us what? H2O. Okay? We have introduced what? Oxygen in the product. Alright. And also by doing that, we have introduced another foreign body into the reaction. Look at this now. At this point, we don't have hydrogen, but we have hydrogen here. What does Route 3 says? Balance the hydrogen using what? Using hydrogen ion. So at this point, what do? Move this hydrogen to this place. We have plus H plus. Is that okay? Now, oxygen is not balanced. We have 7 atoms of oxygen here, where they have only 1. What do? Move this 7, okay, to this point. We have balanced what? Our oxygen. So oxygen is 7, oxygen is 7. 7 times 1 is what? Is 7. Is that okay? Now we have introduced extra number for what? For hydrogen in the product. So 7 times 2 give us 14. But here we have just what? Just 1 atom of what? For hydrogen. So what should we do? For 7 times 2 give us 14. So we now have 14H plus. So we have balanced both the chromium, the oxygen, the hydrogen in this reactant. Now the next test for you to do is to try and balance what? The electron. Is that okay? Now you also balance the charges using the electrons. Okay, put the electrons on the most positive side. At this point, how do you know the side that carries less charge? Now let's look at this together. Be careful here. Now we have 2 minus plus 14. Is that okay? At this point. So the number of charges we have is minus 2 plus what? Plus 14. Okay? The number of charges is equals to what? Equals to plus 12. Don't forget. But here we have a charge of just plus 6, which is 2 times plus 3. That gives us what? Plus 6. I'm looking for a way to make sure that I have both equal number of charges, both at the reactant and also at the product. Is that okay? So at this point now, what will I do? I don't need to add electron to this point again. What I need to do, I need to add extra 6 electron to what? To the reactant. So that I can have the same number of charges at the both sides. Is that okay? So if I add 6 electrons here, that will give me what? This is like 6 times minus 1. This is plus 12 minus 6. That equals to what? Equals to plus 6. So at this point now, my equation is balanced. What will I do? I'll just add plus 6 electron. Okay, so everything here is balanced, both at the reactant and also at the product. Electron is balanced, 6 electron, 6 electron, 2 chromium, 2 chromium, 7 oxygen, 7 oxygen, 14 hydrogen, 14 what? Hydrogen. We are done with the reduction half equation. Now let's go to the oxidation half equation. Oxidation half. All right, equation. Okay, so from plus Fe2 plus to Fe3 plus. At this point, all right, this one is very easy because we have just 1 atom present, and the 1 atom we have is balanced. 1 electron, 1 ion, 1 ion. But the electrons is not balanced. What do? Here we have 2 plus electron, here we have 3 plus. I want both sides to have what? They have the same number of electrons. So what should I do? I simply add what? 1 electron at this point. So plus 2 minus 1 gave us what? Plus 2. So at this point, my charges are balanced. Plus 2 in the reactant and also what? Plus 2 at the product, because plus 3 minus 1 equals to what? Plus 2. Is that okay? But at this point now, how do I get my overall equation? I must make sure that I have the same number of electrons at both reactant and the product for me to be able to do what? To get my overall equation. So what should I do that? Now, looking at this point, in the reduction half equation, I have 6 electrons. Don't forget. Then in my oxidation half, I have what? I have just 1 electron. But I want to make sure that both sides, both halves, I have the same number of electrons. What do you think I should do? Now relate this to your mathematics. If you are solving simultaneously in an equation, you must make sure that one item is the same, so you can eliminate and get the other part. So I multiply this by 6. Okay? If that is done, that will give me what? 6 Fe 2 plus, that will give me what? 6 Fe 3 plus. Alright, then 6 times E give me what? 6 E electron. At this point, I have the same number of electrons. So that takes me to what? So we call the overall redox equation. What would I do? Call this equation 1, call this equation 2, and now say add equation 1 to 2. How do you add this one on the 2? Reactant to reactant, product to product accordingly. So how do I start? We have Cl2O7 2 minus plus 6Fe 2 plus 14H plus, okay, plus 6E minus, all right? That is all I have in the reactant. That means that every reactant comes together, all right? Then every product will come together. So the product will give me what? 2Cl 3 plus what? 6Fe 3 plus 7H2O plus 6E minus. So something is common for the both, for the reaction equation, which is what? Your 6E will do what? Cancel your 6E. Then what you have here will be your overall redox equation, which is this. So it's not difficult. Just follow the steps, all right, and the rules involved. You'll be able to balance your redox equation both in acidic medium and in basic medium. But in this video, I will not teach you basic medium today. Maybe next time you will look at the basic medium. But this is where WAEC and NECO always pick their question from, acidic medium, all right? So follow the steps involved, all right, and look for more examples and see how you can balance it. All right, so let's move to the next and see some other examples. All right, so this is like a classwork in which I know you know what the answer is, all right? Determine the value of P, Q, and R. This is how the question comes in OBJ or in JAM exams. So your work is to look at what is the value of P, what is the value of Q, and so on and so forth. So it's easy. At this point, all right, you should know what P is. You should know what Q is. Is that okay? So at this point, how do you get your R? Your R comes from number of oxygen here. Okay? So this is 7 oxygen. So if you multiply this 7 here, you have balance in oxygen. Okay? Then how have you done that? What should be your H? So 7 times 2 will give us what? The P. All right? Then after you find the P, try to make sure that you've balanced the charge and you will know what is done. Okay? That is not what difficult. So your P equals to 14. I explained that how we got the 14. Then your R is 7, in which I tell you how you get the 14, the 7, and your charge all right, to make sure that your charges correspond, both the reactants and the product are the same. Okay, then the next example is, what is the value of X, Y, and Z in this reaction? Take note, this is your OBJ pattern of question, all right? So you want to know this. How do you know it? Look at the question critically and try how you can fix this. Now, at the first point, you balance oxygen with water. So if oxygen is 4 in the reactant, how many moles of water can you add to give us oxygen? That is what? 4. So your Z will be 4 automatically. Okay? So having known that your O is 4, you have introduced H to this compound, right? So 4 times 2 will give us what? The value of X. So it's very easy. So we have your X is 8. You know how we got that? I believe you know. Then your Y is what? Is 5. This is the charges. We have a charge of +2. So what value should we add here to make sure all of this is what is the same thing? So we add Y here and find out Y will be 5. And your Z is 4. Gotten for where? The atoms of what? Of oxygen that is present.